Okay, let's give you guys some more practice. So here, find the limit of this here as x approaches 0. As a clue, in the past, I've always told you to keep an eye out for this sine x over x over x. And then when you take the limit of this as x tends to 0, this whole thing here will the limit will be 0. I've always told you to keep an eye out for this thing here. But now in this case here, you've got this sine of x at the bottom. So here you've got something like this, 3, you will come to this stage here. And then what you do is you times top and bottom here by 3, because your aim is to get this to be the same as this. So times top and bottom by 3, and then you will get to something like this. And then you've got a scenario where instead of sine of x being on top, you've got the x or over sine of x. So in this case here, you've got something like this. Hang on, you've got something like 3x over sine 3x. So here, what you do when you're here is to divide. This is just a trick. Divide top and bottom here by 3x. So you will have something like this. 3x over 3x, and then over this here. Hang on. Yeah. So you will have this here, sine 3x over 3x. Visualize as this. You visualize it as one number, if you like, and then here you've got another number. And then this here is just 1, and then now this is something that you understand. This is something that we've seen before, sine x over x. This is like sine of x over x. My point is that, hang on, my point is that normally I would tell you to keep an eye out for sine x over x. You see this here, you constantly have to keep your eye out for this. But now you've got a situation where you've got sine, where you've got x over sine of x. So the trick here, even if you have something like a 3 here, the trick is to divide top and bottom by 3. So here you have this 3x over x, and leave this as a number here, and then you've got sine 3x over 3x. So this here is like another number here. Well, do whatever you want. Find the limit of this here. So press pause and have a go. Okay, so to do this here, visualize this thing here as an x times an x times an x here, and then down here visualize it as this block here multiplying with this block here, because that's what you've got at the moment. Okay, yeah. So here at the moment we've got this block times this block here. Well, when you're here, multiply top and bottom by 3, because your aim is to get these to somehow get it to have 3x. So what you do is times top and bottom by 3. Then this x here will be down here. This one here will be this one here, and then 3. You could put the 3 up here, but we're going to stick the 3 in here. Okay, so here when you're here, times top and bottom by 3. So you have 3 blocks here, and then the bottom, when you times it by 3, let's just put the 3 in front here. So down here you have 3 blocks here, multiplying with each other. Now break up this fraction. So it's like this. Break this fraction up. So you've got take the limit of this, and then take the limit of this here. So this here, yeah. So it would take you to this stage here, and then use the same trick on this thing here. So times top and bottom here by 3, because your aim is to get these two to be the same. So let's just times top and bottom by 3. So when you are here, you've got this block times with this block here, because remember you're timesing top and bottom by 3. So down here you have a 9, because here you've already got 3 here, and then later on this 3 will merge with this 3 here. That will give you 9 here. So down here you have a 9, well here, can you see these two are the same now? So let's just break this fraction up down here. Break up this fraction here. So you have this here. Okay, so but basically take the limit of this, which is this one here, and then take the limit of this here, which is this one here, and then well this was what was left from earlier. Okay, so basically now we've got three limits multiplying with each other. So hang on. So when looking at this, so basically we've got work out this, and work out this. These two are exactly the same. Okay, but here we've got a situation where in the past I would say keep an eye out for sine x over x. But here we've got a case where we've got 3x over sine 3x. So here the sine's at the bottom. So what we do is we use this trick. Hang on, let me just jump over to a different screen. But just looking at this only, okay, let's just concentrate on finding out this first. By the way, this is the same. So, but let's just concentrate on finding out this first. So this, I'm going to jump to a different screen. Hang on. So here, we are here at the moment here. So what we do is we divide top and bottom here by 3x. Divide top and bottom by 3x. So 3x over 3x, well that's 1. And then this thing here is what we're used to. Well, as x tends to 0, the limit of this thing here will be 1. Okay, we've done lots and lots of videos on why sine x over x is why the limit is 1, and the same goes with sine 3x over 3x, because as x goes to 0, then this bubble here will automatically go to 0 anyway. Well, anyway, so the limit of this here, the limit of this whole thing here will be 1 over 1, which is 1. So the limit of this here is actually 1. Okay, but don't forget, well, I'm going to jump back to the previous screen now. Don't forget, all that we've done is worked out the limit of this as x tends to 0. Okay, so going back to here, so we were at a stage where we've got to get this times with this times with this here. Well, the limit of this here is 1. Okay, so this is also 1 because we worked it out earlier. So now looking at this, hang on. So now this limit here is actually 1, and then this here is also the same thing. And then, well, let's just concentrate on finding out the limit of this. So 1 times 1 is really 1, so we can pretty much forget about this. Let's just concentrate on finding out the limit of this. So the limit of this, yeah, so basically this whole thing here boils down to this, because 1 times 1 is 1, and then you times this thing here, leaving you this. Okay, so now the limit of this as x tends to 0 would be 0 over 9, which is 0, because nothing really breaks down. Here you are allowed to have 0 divided by 9. You're just not allowed 9 over 0. So 0 over 9 is okay. This here is bad, but here we've got 0 over 9, so it's okay. Nothing breaks down. Okay, so the limit is 0. And when you look at the graph here, when you look at the graph of what we were trying to find out, as the limit as x tends to 0 from the left hand side, it will be here. Okay, and then from the right hand side, as x tends to 0, it will be right here. And so dead on 0 is undefined, but the limit will be 0. Okay.